Hello, I'm Zhuoyue, and welcome to my channel. In this video, we want to talk about generative models. Generative models is a kind of unsupervised learning, which means learning the underlying structure with unlabeled data. It's kind of like learning without a teacher. For example, we as humans can learn how to play a video game by watching other people play, and we want the machine to be able to do it too. The generative means once we learn the underlying structure, we can create new examples that do not exist. Let me show you a video from MIT that's gone viral on the internet.
Hi everybody, and welcome to MIT 6S191.
The official introductory course on deep learning taught here at MIT.
He used the generative models to create fake Obama voice and other characters' voice. There are many kinds of generative models, but we want to focus on the two most popular ones, VAE and GAN. To talk about VAE, we should first talk about what is AE, that is autoencoder. Imagine we have a data set of written digits. The autoencoder would first encode the image into a latent space, Z, through an encoder, which is layers of neural networks. And then it will reconstruct an image from this latent space through decoder, which is also layers of neural networks. The latent space Z is usually low-dimensional, forcing it to contain only the most important information and discard the irrelevant information. For example, here's our latent space. We can see that all the images that are 1 are clustered in one area. Images that are 7s are clustered in another area. However, the latent space generated by autoencoder is not continuous. If we're interested in the thing between 1 and 7, we can't just take the center point and reconstruct the image because there's no point there. So we need VAE, which is Variational Autoencoder. Instead of encoding the input into a single latent vector, we encode the input into two vectors, one vector for the means and one vector for the standard deviations. These two vectors parameterize a probability distribution of the latent space. Thus, we'll be able to sample from this distribution and generate new output. For example, here we have digit 8 on the top left, 1 on the bottom right. Everything in between is samples reconstructed from the latent space. GAN is pretty interesting. It has two networks that's competing against each other. The goal of the generator is to fool the discriminator by generating real-looking images from random noise, while the goal of discriminator is to tell the real and fake images. At the beginning of the training, the generator creates obviously fake data that the discriminator quickly learns to tell that is fake. As training progresses, the generator gets closer to produce output that can fool the discriminator. If training goes well, the discriminator gets worse at telling the difference between real and fake. It starts to classify the data generated from the generator as real. At this point, we can use this generator to create fake data. For example, the fake Obama video that we saw before. To me, the main takeaway from this generative model thing is the idea of latent space. So this tiny little vector is kind of like the truth behind the written digits, behind Obama's faces, and the truth behind this world. So in the past, we as humans tried to capture this truth from theories and formulas. For example, the quantum mechanics and classical mechanics explain how the object moves from atoms to cars to airplanes, even to stars. But nowadays, using machine learning, we are unlocking this truth not through theories and formulas, but through thousands of iterations of a mathematical model. And sometimes the truth captured from this model is something we can't even explain. So this triggers a very interesting question. What if one day we can learn latent space of everything, even the universe itself? Are we able to reconstruct a new world from this latent space? If there was a creator of this world, did he or she uses some kind of latent space to construct us? Okay, enough fantasy. So thank you for watching my video. If you like this video, please click thumbs up and subscribe to my channel. And if you're interested in more contents about machine learning, check out the links I posted below. Thanks for watching and see you next time.